This lesson is about solving by inverses. We already know how to solve by quadratic formula and by factoring. Why do we need to learn a third method of solving with inverses? The reason is because of standard form. In order to solve by quadratic formula, you need an a, a b, and a c value to substitute into the formula. And to be able to factor a trinomial or a binomial, it has to be in standard form, so that we know we first take out the greatest common factor, that would go here, and then we would ask ourselves what times what makes the first term, what times what makes the last term, and we would go through our factoring process. This is not in standard form. I would have to apply this exponent, and remember, squaring means something multiplied by itself. I would have to do the double distribution, subtract the 4, somehow get the 32 over onto this side, and turn it into standard form. That would be a big headache, so let's solve by inverses instead. Here's the symbolic process, how to do this first example. We're going to go through this and answer the prompts as we go. The first thing it says to do is add 4 to both sides, and I'm doing that why? Because subtract and add are inverses. The next thing I need to do is use the square root property. So -4 and 4 are inverses. There's no more 4's here. 32 plus 4 is 36. Now I need to do something about this exponent. And the exponent of 2 and the square root are inverses. And so when I do the square root of one side, I have to do the square root of the other. This square root and this square are inverses, and that's why what we have left on the left-hand side is just the x plus 5 that was in the parentheses. I don't need the parentheses anymore because the square was there to apply to the binomial. Since I did the inverse of the square, I don't need those parentheses to define that binomial anymore. And finally, let's talk about why this is a -6 and a 6. How come one equation got somehow split up into 2 equations? Well, isn't it true that 6 times 6 is equal to 36? Yes, it is. But isn't it also true that -6 times -6, a negative times a negative, is a positive 36? Yes, that's also true. So when I use this square root property, I have to think about the negative and the positive roots of 36. This is how we're moving from middle school on to high school. In middle school, you only had to worry about the positive root. Now, when we're using square root property as an inverse, we have to think, if I'm square rooting 36, I have to remember there is a positive and a negative root. So now I have 2 equations. And from there, this looks like every other equation you've been solving. We would just subtract 5 from both sides. That would give us -11. That makes sense in terms of this intercept. And then if we subtract 5 from both sides here, that would give us 1. That makes sense in terms of this intercept. It says the x-intercepts of the function, sorry about that, I know you couldn't see. -11 here, 1 here. The x-intercepts of this function are shown in the diagram. Yep, we got them. And then it says, how does this equation, this one here, relate to the equation at the beginning? The equation at the beginning was x plus 5 quantity squared minus 4 equals 32. Somehow it's telling us that these 2 equations are related. Here's the one from the beginning. Here's the one that is graphed here. How do these relate? Well, what would happen if I took the 32 and I used its inverse and moved it over to the left-hand side? Then I would have x plus 5 quantity squared minus 36 equals 0. And this equation is exactly the same as this equation, but f of x has been replaced with 0. Why is that important? I'll tell you why. because of these zeros here. When we have an equation that's equal to 0 and we solve it, we are looking for these x-intercepts. What we're saying is the inputs of -11 or 1 will give us an output of 0. Now, this isn't the most important part of this lesson. This is just to show you how what we've been learning in the past is related to what we're learning today. What our objective is for today is to make sure that you know how to solve by inverses. But take a little break right now, see if you can identify the key features of this function shown in the diagram. The answers to those questions will be shown in the next video. And over 6 from this way. And that would be an axis of symmetry of x equals -5. Remember, that axis of symmetry always has to be in an equation. To find the vertex, which would be the lowest point on the parabola, you take your axis of symmetry and you substitute it back into your equation. So I would take my axis of symmetry of -5, and I would substitute it back into my equation. -5 plus 5 is 0, and 0 minus 36 is -36. So the vertex is at -5, which comes from the axis of symmetry, -36.